Let's multiply these rational expressions. We'll simplify by factoring. We have a trinomial as a numerator, and we have x times x is x squared. And let's try 3 times 4 becomes 12. And we'll put the minus sign in front of the 4 and the plus sign here. And they add to be -1, the coefficient of x. The denominator we factor using difference of squares. We have plus 3 and minus 3. And we multiply by this part here again we factor. We have x times x is x squared. And let's try 3 and 1. And minus. These add to be -4. As for the denominator, let's factor out the x. So we have x minus 4. Notice how there's a x plus 3 on the top and bottom here, so they cancel. The x minus 3 we can cancel diagonally here and here because we have a numerator and a denominator. Furthermore, we can cancel x minus 4 and x minus 4 here. So what's left over is just x on the bottom and x minus 1 on top. So we have x minus 1 over x. Now let's focus on the domain. It might be tempting to say that x does not equal to 0 because we cannot divide by 0. But we have to consider where else we divide by 0 for any single step as we simplify this expression. So let's focus on the denominators here and here. When we have the factor x plus 3, we know that x does not equal to -3 because -3 plus 3 is 0 and we can't divide by 0. So we say that x does not equal to 3 as well because 3 minus 3 is also 0. Anything divided by 0 is not allowed. We also have the factor x minus 4 here. Thus x also does not equal to 4. So x can be everything except for these values. Let's divide this rational expression. We have the numerator and we factor using difference of squares. X plus 2, x minus 2. Here we factor out the GCF x and we get x minus 2. Let's change divide to multiplication. When we do so, we flip the numerator and denominator. Let's change this division symbol to multiplication. And by doing so, we flip the numerator and denominator. We have x squared plus 3x plus 2 on the bottom. And we can even factor this to be x times x is x squared. And we have plus 2 plus 1 multiplies to be 2 but adds to be 3. We see that the numerator and denominator x minus 2 cancels. And so does x plus 2 here and here. Furthermore, the x's cancel as well, leaving only 1 on top. There's a hidden 1 on top. And the only remaining factor on the bottom is x plus 1. So we have 1 over x plus 1. Now let's think about the domain. It's not only x plus 1 does not equal to 0, which results in x does not equal to -1. It's every step of the way where we divide it by 0. Here, here, and here. We see that x does not equal to 0. The opposite of -2 is +2, so x does not equal to 2, as well as -2 here. So x can be all real numbers except for these values here.